Hello everyone, and in this video, we're going to be taking a look at a problem from the 2023 ELMO, specifically problem 4. And this is an Olympiad that was held only a week ago. So without further ado, here it is. Suppose you have a triangle ABC, and E and F are the feet of the altitudes from B to AC, and C to AB. And these altitudes intersect at a point H, which is the center of triangle ABC. And then you have a line through A parallel to EF, and there's a point X on it such that HX is perpendicular to this line. And then you have the line XF intersect the line through B parallel to AC at B1 here. So BB1 is parallel to AC. And similarly for C2. So CC1 is parallel to AB, and it lies on line XAE. What we want to prove is that BB1C and C1 are concyclic. They all lie on the same circle. Let me go ahead and remove that so that our diagram looks a bit cleaner. There we go. So how can we go ahead and get started on this problem? We definitely want to use a parallel line somehow. So we start looking for some angles that we can use that might not be as obvious. Obvious angles mean like this one here, which is obviously equal to 180 minus this one here. ABC is 180 minus BCC1. So let's try looking for non-trivial applications. We could try relating something to this angle here, so might as well. Let's go ahead and extend this to meet the line AC at a point called a Z. Because we want to use the fact that this line is parallel to this line here. But at this point, we might say something even stronger. We might notice that about this point Z, we have that triangle ZXA and triangle ZEF are isosceles. This is a really interesting fact, and this would really help us since if BB1Z is equal to AZX, it would help us relate in terms of these other angles here. So how can we get started on proving this? Note this is equivalent to proving that AXFE is an isosceles trapezoid. In other words, since AX is parallel to FE, it's also equivalent to proving that AX, F, and E are concyclic. So let's go ahead and draw the circle to see what happens. There we go. And coincidentally, it seems like it might pass through H. Is it a coincidence? Let's see. Let's try proving that the pentagon HFXAE is concyclic. But this is pretty easy as directed angle HFA is equal to directed angle HXA because it's a foot of the altitude. X is a foot of the altitude from H to this line, sorry. And it's also equal to directed angle HEA, which is 90 degrees. So that means that all of these points are concyclic. Specifically, we know that AX is parallel to FE, so it's an isosceles trapezoid. So now we know that ZXA and ZEF are isosceles, and that's a fact. So we can then say that directed angle BB1Z is equal to directed angle AZX, and we can now relate it to the other ones. By the sum of the angles in a triangle, we get directed angle AZX plus directed angle ZXA plus directed angle XAZ is equal to 0 degrees. But we note that directed angle ZXA is equal to directed angle XAZ because of the isosceles trapezoid and the isosceles triangles. We end up getting directed angle AZX plus 2 directed angle XAZ is equal to 0, which means that directed angle AZX is equal to 2 directed angles ZAX. Because directed angle XAZ is negative directed angle ZAX, because they're in the opposite order. But we know that this is equal to directed angle ZEF because of the parallel lines. And now we can say something even further about ZEF. Here's Z. Because Z lies on line CE, by definition, we can say that this is directed angle CEF. But it's pretty well known from these right angles here, BFC and BEC, that BFEC is cyclic, which means that this is just 2 directed angle CBF, which in turn is 2 directed angles CBA. So now what? If we try looking closer at the diagram, we might conjecture that XB1C1 is similar to ABC. And this is a really interesting observation. So we already have one angle here, FXC and FA are equal, so that's one part. But we need to prove one other angle. So let's go ahead and draw the line between B1 and C1 and see where that leads. So we can let it intersect at point, suppose, W. And we notice something right off the bat. It appears that W is a midpoint of BC. So let's try proving this using phantom points. In other words, we let the midpoint be some other point, suppose M, and this intersection point is W. And we wish to prove that W equals M. So let's try doing this. We can say something about the point M because it relates a lot to cyclic quadrilateral BFEC. It is specifically the circumcenter, which means that triangle BMF is isosceles. As a result, we know that directed angle BMF plus directed angle MFB plus directed angle FBM is equal to 0 degrees. But directed angle MFB is equal to directed angle FBM. So that means that directed angle BMF plus 2 directed angle FBM is equal to 0 degrees. And as a result, directed angle BMF is equal to 2 directed angle MBF. And noting that M lies on BC and F lies on AB, this is just 2 directed angles CBA. Recognize this? It is just equal to directed angle BB1Z and that's equal to BB1F. BB1Z equals BB1F, which is also equal to BMF. So therefore, BF and B1 is cyclic. So let me go ahead and draw that in. Similarly, CC1EM is also cyclic. So we can go ahead and draw that in. And this quadrilateral here is cyclic because of similar logic. So now that we have these cyclic quadrilaterals, what can we say about directed angle B1MC? We wish to prove that directed angle B1MC is equal to directed angle C1MC. And here's where a huge angle chase comes. We have that directed angle B1MC is equal to directed angle B1MB. And because of the cyclic quadrilateral is equal to directed angle B1FB, and because A lies on line BF and X lies on line FB1, we have that this is just directed angle AFX. Actually, whoops, it's supposed to be XFA. But now we know that directed angle XFA is equal to directed angle XEA. So this is directed angle XEA. And from here, we just work backwards again. We have XEA is equal to C1 EC, which is just C1MC, which is what we wanted to prove here. So now we know that these points are that B1C bisects this length. So now we can go ahead and get rid of this point W and say that the midpoint M is indeed the center. So now we wish to prove that BB1C C1 are concyclic. And to do so, we will prove that BB1C is equal to BCC1. But this should be easy because directed angle BB1C1 is equal to directed angle BB1M, which is equal to directed angle BFM because of their cyclic quads. And this is just equal to directed angle MBF, which is just directed angle CBA. But because of the parallel lines, this is equal to directed angle BCC1. Therefore, BB1C C1 are concyclic, and we are done. So thank you so much for watching this video. Please subscribe, and I hope you enjoyed.